to understand some of those things we did. I mean, some of the questions that were solved, that you solved. Did you I hope there was no issues with them. I hope you didn't encounter any issues.
Mm, some of them, some of them were kind of hard.
Sorry?
I
So,
wasn't able to do some of them.
okay.
I could not do some of them.
Like which of them?
Um,
Were they calculations? Those questions were not able to do. Was it one
yes,
that involved calculations?
no.
Okay, they were not calculations.
They involve calculations.
Okay.
They were calculations.
Okay, would you want us to check them out?
So I joined the meet, but it's saying I cannot join with my school account.
Sorry, what did you say? We'll be looking at properties of waves. Another this we'll be looking at reflection, refraction, interference, diffraction, poly, polarization of waves, progressive and stationary waves. Okay, when we talk about reflection, what do you understand by reflection?
When light shines on an object and the light shows back.
You said
When light shines on an object,
okay. Okay, that's reflection.
yes.
Okay, what about refraction?
Mm, mm, mm.
What about refraction?
Good grammar and spelling are important, but if you
Like refraction is bending of light.
Yes, the bending of light.
good
Okay,
grammar and spelling are
sorry. Coming, what's this? Okay. Now, when we talk about reflection, reflection is actually the bouncing back of a ray of light after striking a reflecting surface. Reflection, reflection has to do with the bending of light rays. But we can also say in wave form, we're talking about reflection occurs in wave. Sorry, I think I'm having a. Okay. Um, sorry. Just give me some minutes. Okay. Sorry. Come in. Just some minutes. Okay. Um, where are you? Come up. Okay. Now, good. Like I was saying, when we talk about reflection, reflection has to do with that's in waveform. Reflection occurs in waves when they encounter an obstacle and they are made to propagate in the opposite direction. Reflection, I said, occurs. Please write that. Reflection occurs in waves when reflection occurs in waves when they encounter an obstacle and they are made to propagate in the opposite direction. What am I trying to say? For example, if we have a okay, if we have now the direction flows here, that's is incident here and is reflected. So it occurs when the wave encounters an obstacle and yet it's made to propagate in the opposite direction. That is what reflection, that's what we call, that's what reflection is about. Now, but when we talk about refraction, like you said, when we talk about refraction, refraction has to do with the bending of a ray of light. But before I go into refraction in details, reflection also occurs in sound and light wave. In fact, that's the purpose of this. A reflection occurs in sound and in light wave. Now, the question is this: you understand that reflection occurs in light because when you shine, the reason why you can see yourself in the mirror is because the ray of light strikes the reflecting mirror, the reflecting surface, which is the mirror, and the only thing you see there is your face. Now, how does reflection occur in sound? How does reflection occur in sound? Reflection occurs in sound in form of echo. Please write that. Reflection occurs in sound in form of echo. Reflection occurs in sound in the form of echo. Echo. How do I mean, or what do I mean by that? Echo is a reflected sound wave. Now, one of the animals that use this a lot, we have the dolphins or the sharks and the bats. The bat is a very common example of echo. How does the bat do this? When the bat, most times it is known that the bats do not or they can't see. So what helps the bats to fly in the night? They use the sound wave, they use the echo. When you make a sound, when you make a sound, probably in an empty room, the only thing you hear a, will I say, a slowly repeated version of what you've said. That's why some people, when they the forest, they hear, hello, hello, oh, how are you? How are you? Are you? No, it becomes very, very low. Now, that sound alone is echo. Why is it able to reflect back? That's because sound reflection also occurs in sound. An echo is a reflected sound wave. Now let's come quickly to refraction. Refraction is the change in speed and direction of wave. Refraction is the change in speed and direction of wave. Refraction is the change in speed and direction of wave as they cross the boundary of two media. As they cross the boundary, as they cross the boundary of two media. As they cross the boundary of two media of different densities. Of different densities. Now, what we are trying to say is explain the reason why we have this explains why we have different different. Okay, what I'm trying to say is when you take a pencil in water, the pencil appears bent in water because of refraction. The pencil appears bent in water because of refraction. Okay, let me see. Let me share a slide with you. I think um that would explain better what I'm trying to pass out now. Okay. Okay. Where are you? Where's this material? Um, yes. Okay, we are here. Correct. We are here. The light wave. Awesome, awesome. Beautiful, beautiful, beautiful. Okay, that's okay, 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 okay. That's a very good one, I guess. Oh, come on. Okay, can you see my slide, please?
Yeah.
Can you see the slide?
Yes.
Okay, okay. Now, we're just trying to look at a plane mirror, and one of the things we should understand in that reflection in a plane mirror is that the angle of incidence. You may not need to write this. I guess you've done this before. I'm just trying to just go through them. Now, the angle of incidence is equal to the angle of reflection. I hope you know what we call the angle of incidence, right? This is the angle of incidence here.
No.
Okay. Now, the angle of incidence, we know definitely that this is the angle of the incident ray, the ray that goes into the mirror. That's the incident ray. Then we have the normal, the angle of reflection, and we have the reflected ray. Okay, so now now this is what I was trying to talk about, that when light travels from one substance, it changes direction. So refraction is actually the bending of a beam of light, or the changing direction and speed of a wave when it passes from one medium to another. Now, the fish actually appears to be here, but this is the real position of the fish. Because of that, the man who tries to kill the fish, his eyes, because of the refraction of light on this fish, he would actually think this is the fish. This is what we call real depth and apparent depth. due to refraction. Real depth, apparent depth. Real depth is actually the actual depth of the object, but apparent depth has to do with um, the position of the object, the supposed position of the object due to refraction. Due to refraction, and this is exactly what happens because it passes from air to water. So that was what I was trying to talk to you about. Okay, now we know incident angle, that the incident angle is the angle the direction of the incident wave make with the normal, and the angle of refraction is the angle of the refracted ray with the number. I hope you know all that, please.
No.
Oh, I'm sorry. I was just assuming you knew all that. Okay, let's go back then. Let's go to this. Okay, if that's the case, I need you to draw this. I need you to draw this. See this direct. Look at this position. I'm coming. Um, look at this. Whenever you see the direction pointing to the mirror, this object indicates that this is a mirror. Whenever you see the direction pointing towards the mirror, that shows that that is the incident ray. And whenever you see this direction pointing out of the mirror, that shows that is a reflected ray. Now, the angle between the incident ray and the normal is actually the perpendicular line between the incident ray and the reflected ray. Okay, now the angle between the incident ray and the normal is called the angle of incidence, and the angle between the reflected ray and the normal is called the angle of refraction. Okay, I hope you've gotten that now.
Yes.
All right. Okay, let's continue then. Now, most times, one of the things we should understand is that the angle of incidence will always be equal to the angle of reflection. These are the rules, or these are the laws of reflection. That the angle of incidence will be equal to the angle of reflection. Even in refraction, that's the same thing. That the angle of incidence will always be the angle of reflection. Okay, now that we know what the incident angle is, the incident angle is denoted with I, and the refracted, the angle of reflection is always denoted with R. Okay, now what we just did was for reflection. Let's see refraction diagram. Oh, I don't have it here. Come on. Oh no. Okay. Now this is an example of it. This is an example. Now this is passing from air into glass and then into air. Now, what do you think this angle is? Or what do you think this line is? What is it?
Incidents. Yeah.
Yes, this is the incident ray. What's this?
Normal. That's
Yes,
normal.
normal. What's this?
Angle of incidence.
Okay, angle of incidence. Okay, what's this?
Angle of reflection.
Angle of what?
Reflection.
No, that's not true. That's not the angle of reflection. What's this?
Angle of refraction.
Correct. I wanted you to know the difference. Refraction, angle of refraction. Okay, okay. Now that's exactly what I wanted you to be conscious of. And what's this?
Mm, refractive wave.
Yes, refracted ray. So, okay. Oh no, sorry. Oh, come on. Um, all right. Now, there's something we call the refractive index. And the refractive index is always the refractive index. Now, when we have two medium one, I told you that refraction has to do with two medium of different densities. So that means when we have a refractive index would be the speed of wave in medium one divided by the speed of wave in medium two. Okay, what am I saying? That refractive index will be equals to the speed of wave in medium one over the speed of wave in medium two. Okay, now if the wave passes from deep sea to shallow water, if the wave passes from deep sea to shallow water, that means refractive index would be the speed of wave in deep water over the speed of wave in shallow water. The refractive index is going to be the speed of wave in deep water divided by the speed of wave in shallow water. Now, another thing we must know about refractive index is that refractive index is equal to sine I over sine R. Okay, now this is the refractive index. Now we have talked about, you might be asked to, you might be asked to draw the Lebesgue diagram of the angle of refraction when light travels from air to glass. When light travels from air to glass, what the first thing you do is you draw a this is a ray diagram. This is your normal. When light travels from air to glass, then this becomes your angle of incidence, incident ray, angle of refraction, then your refracted ray. So this is a ray diagram. Most times they will ask you to draw and label a refracted ray diagram as it travels from air into glass. Okay, so you must be able to understand that. Now, let's look at interference. We have looked at two properties of wave. Number one, reflection. The wave reflects, they bounce back. When they strike a surface, they bounce back to the opposite direction. Number two, number two is refraction. Number three is interference. Interference. Okay? Now, what is interference? Please write this. Interference is a phenomenon whereby two or more waves of the same frequency interference is a phenomenon whereby two waves, okay, let me put that down for you. Interference is a phenomenon whereby two or more waves of the same frequency amplitude traveling in the same direction are superimposed or overlap on each other. Okay, now where two or more waves of the same frequency, the same amplitude, the same wavelength, traveling in the same direction, then what happens to them? They become superimposed on each other. That's what we call interference. Most times it happens. Oh, I can remember. I wouldn't know if you listen to radio a lot. But I think I remember in the days of black and white TV, sometimes when they used to use this very long antenna, I remembered some time ago, you would be in your house and your TV, your black and white TV will be picking other stations somewhere else. Then we didn't know why it was happening because we're surprised that, come on, we didn't have this station before. How did we get this? What was just happening was interference. Now, right, we have two types of interference. Number one, we have constructive interference and destructive interference. Okay, I think I have to show you a video from here. Okay, let me see. Okay, okay. There's no need for this one. Um, Let me see this. Okay, okay. I think we need this particular one. Let's see a video on this. Okay, good. All right. Can you see can you see my screen?
Yes.
Hi, it's Paul Anderson, and this is Disciplinary Core Idea PS4A, which is on wave properties. Waves are incredibly important, and they're relatively simple to understand, but most students don't get it. And so the first thing you should understand is that there's really only two ways that we can move energy from place to place. If I want to move energy from where I'm at to somewhere else, I could do it using particles. I could throw something around the room. Or I could use waves. So I could use my voice, or I could use light, or I could also use electric currents to move energy from place to place. And so they're incredibly important, and they have relatively few properties. And so what is a wave? It's simply a disturbance. And if we look at a typical wave, they're all going to have a wavelength, and that's going to be just the distance of a wave, how big a wave is. We could measure it here, or measure it from crest to crest, or trough to trough, but it's how long that wave is. Also, they're going to have a frequency. Frequency is the number of waves you're going to have in a given period of time. So if you were to listen to a real low frequency sound, that's going to be a few number of waves in a given period of time. But if it's a high frequency sound, it's a lot of waves in a given period of time. And these two things are related to the medium that it's moving through. And that's an important characteristic of waves. Waves are moving through a medium. So for example, sound is moving from my voice to the microphone through air, but the medium doesn't move. The air doesn't move. Well, how could I change the medium that I'm speaking through and change the frequency of those waves? Have you ever inhaled helium? What does that do to your voice? Well, it changes the medium of the air inside your vocal cords, and you get a high pitch frequency. Likewise, if you had a real low density gas that you were to breathe in, you'd have a low frequency or a low noise. What's another property of waves is going to be their amplitude, or it's the size